So we're going to have a look at three terms in sequence: mutually exclusive events, complementary events, and independent events. If you want to look at this in the textbook, this is page 322. So the definition of mutually exclusive events is that they cannot both occur. And we could look at an example of this in a Venn diagram. So here's one of the examples from investigation 9 on page 321, where you have two events, A and B, where these are rather students who study either art or biology or both. So here you do have the option of both events happening at the same time, that one student can study both art and biology. And the number of students who do that is 4. So these events, art and biology, are not mutually exclusive. And we could look at another example. And here's another example from investigation 9, where you have the two classes, art and biology, and these are mutually exclusive because they cannot both occur at the same time. And we could also notice that the intersection, we could write that as the probability of the intersection between A and B is 0 because the intersection is empty. And with set notation, we would write that as like this. So the intersection between A and B is empty, and this sign here signifies the empty set. So this means the empty set. So if the intersection is empty, then the probability of the intersection is 0. And this is always the case. If the intersection between two events is empty, they are always mutually exclusive. Whereas if there is something in the intersection, then it's obvious that these things can happen at the same time, because there are some elements in both sets at the same time.